So this is turning out to be a lot of fun. I mentioned in my previous video that I wanted to make myself a GyroCompass, and I'm certainly learning a few interesting things. As much about 3D printing and motors in general as anything else. The first thing that I needed to do was to build myself a flywheel. The first flywheel that I built was this one. And it was kind of based on the flywheel that I had in the introduction. A nice, fairly fat, wide one, and I wanted to have as much mass as I could, thinking that whenever I would print it out, that it would be reasonably straight, level, plumb in all three axes, and that it would not shake too badly. But and unfortunately, it didn't quite work out. So when I had printed this part out and I was playing with it with the power supply, I realized very quickly that there were a lot of issues going on with this one, and that this whole operation could fail most spectacularly. So if I spin this up, you'll see that it's going to start shaking quite violently. So that told me several things right there. The first was that the printer is not aligned perfectly straight in all three axes. So even though it can print a circle as a circle, the problem is that as it prints each layer one by one, it ends up being off in a drift. So you can see that as it rotates, the whole thing wobbles. So I was thinking, how can I go about coming up with something that can hopefully resurrect this project? And the idea that I had after that was, instead of trying to print this huge flywheel, what if I let this thing spin faster with less mass and hopefully achieve the same amount of angular momentum than something like this? Because this spinning much slower would have the same amount of angular momentum as something lighter that's spinning a lot faster. The second attempt was this one, and I decided I was just going to try printing a puck. It's the same diameter as this one, so I was just basically standardized on 37 millimeters radius, and this one was 5 millimeters thick. And I'm just going with millimeters because those are the units that the printer uses. So it's a lot easier to just code everything in millimeters than it is to try to convert it from one unit to another. So this is 5 millimeters thick by 37 millimeters radius, and this one still wobbles quite a bit. But even then, so when I printed this one out, it did still wobble a lot, and it exhibited the similar kind of wobbling and the similar kind of issues that this one had. But I noticed something else with this one, that as this one was wobbling, it tended to act like a speaker, and a lot of the energy was spent trying to get the air to vibrate. So there's lots of losses in an imbalanced disk that's spinning. There are several things that I've discovered that will hinder the motor's ability to get up to speed, and that will end up driving the motor harder than it's designed to go. So if you torque the motor down, it'll end up drawing more current, it'll start heating more, and it'll probably overheat and cause all kinds of bad issues like that. The first is the fact that everything is shaking. The motor is putting all of its energy into getting things to vibrate, and so it can't build up proper speed. Second thing is, even if you can hold everything from shaking, the fact that the disc is at a slight angle and it's wobbling will cause the air to vibrate and, of course, lose energy in trying to get the air to move. The other thing that I noticed by the time I got to this one, and I was kind of pondering this as to whether or not it was even a possibility, was that I was wondering if the surface is rough in straight lines, for example, like this, then as it's spinning, it could be trying to cause turbulence on the surface and creating air resistance. So that was a third thing that I was thinking. So trying to get this thing to spin up to full speed, I still could not because of what I consider three factors. First, the motor is trying to spin up, but the thing is still shaking. It's imbalanced. The second thing is that even if I can prevent the motor from shaking by holding it perfectly still, the disc is still wobbling and causing it to act like a speaker and move and vibrate the air. And then the third one I was thinking is the surface finish of the disc could be causing turbulence at the surface of the flywheel, and it's causing air resistance. So after this one, attempt number 3 was based slightly different from this one for a couple of factors. One, I was hoping that if I could reduce the weight on the ends of the disc, that any imbalance would be reduced by the fact that there's less mass out there trying to vibrate. So attempt number 3 was a disc that's shaped, that's tapered from 5 millimeters at the shaft to 2 millimeters on the edge. And I'll show you the other designs that I had after that. But this one here is actually by far the best design. And I was able to, when it came out of the printer, it was vibrating quite badly. At this point, a lot of the noise is caused by the shaft sliding in and out of the motor like this. Like the motor, the shaft of the motor is doing this, and it's causing internal vibrations of the motor. This is the best design so far. Even then, it's still not balanced properly. I was able to get it more in balance by using the file and then letting this thing spin and smoothing off and making the edges as round as possible. After this one, the next one after that, I thought it's still wobbling. So what if I can find a way to let the center shaft wobble all it wants while the outer diameter of the disc finds its rotational level, or whatever you call it, and find its own balance point, so that hopefully as the motor could kind of like wobble like this, but that the outer disc could rotate straight without wobbling this way. So the next design that I tried after that was this one, where I made a relatively thin, although looking at this, I think that it's not quite thin enough. I was hoping that I could have a relatively thin disc that connects the center spindle from the outer ring. And this one here was just as bad as this one, simply because I think that this here is still way too stiff, and it just can't flex. So the next one after that, I thought, well, a lot of the mass is on the outer ring, and I thought, what if I reduce the weight by removing this outer ring and just leave the flat disc? So the last one, the fifth one that I printed out was this one, and it is essentially the center spindle with a fairly flat, thin disc. And this one does spin quite fast, but it was still pretty violent in terms of shaking. Now I've since balanced this one, and this could be a potentially viable alternative flywheel. But when I first printed it out, it didn't. It was actually pretty bad. It was almost as bad as this one. So I discovered something even new, something else even with this one that wasn't with those. This one is just basically flapping in the breeze, and it ends up developing its own internal harmonic resonance, and it starts flapping around as it's spinning, and augmenting the fact that it's off center like that, and creating even more air resistance. Oh, and speaking of air resistance, part of the reason why I tried to go for this one was I knew that whenever this one would print out, that each layer coming up one on top of the other, the printer would end up printing in a circle as it gets up to the top. And I was hoping that the concentric rings from the edge all the way up to the top would offer less air resistance than one of these, for example. These are all just straight lines. And I was hoping that the concentric circles on the surface, the concentric rings on the surface, would end up creating less air resistance, because it would be kind of like a fork trying to push the air like this, as opposed to trying to rake the air like this. So that was the 5 different flywheels, and every single one of them ends up being just out of balance enough to kind of derail this project. But I did keep going, and I'm going to make another video that describes the next part, mainly the horizontal gimbal. And so look forward to that one. I should hopefully have that out maybe in a couple of days. And there's some interesting things that I've discovered already, particularly the forces that act on the gyroscope and how the gyroscope turns in a particular direction. So that's going to be it for this video. If you like this video, give it a big thumbs up and leave a comment in the description below, etc., etc. You know what to do. Bye for now.